For a medium range distance measurement, ultrasonic sensor HCSR04 is a best option. With this sensor, we can also use this in a dark, or it is not color dependent. And in this video, we are going to understand how to interface HCSR04 with Arduino. Hi, my name is Amit and welcome to my channel. In this video, we are going to understand some technical aspects with its datasheet, and we are going to write a code for it and test it out. So let's begin. Here I have this datasheet for ultrasonic sensor, and there are multiple vendors available, and there are multiple datasheets available. This I found the interesting one where they have mentioned it with a good diagram that the ultrasonic working principle. So in ultrasonic, it has a transmitter and a receiver. So what happens is, when transmitter transmits an ultrasonic sound, and when it gets reflected back from the surface, the distance taken from the sensor to the obstacle and back to the sensor, this is how we find out the distance because we know the speed of a sound. So with that, we are able to find out the distance between the sensor and the obstacle. Okay, so this is the great figure, and here we have some specs that the distance measured by this HCSR04 is from 2 centimeters to 400 centimeters. In feet, it is 1 inch to 13 feet. That's a good range, and its operating voltage is from 3.3 volt to 5 volt. So it's great. We can directly hook it up with Arduino. That's great. And the other aspect is its timing diagram. Let us understand with the timing diagram how does it functions. Yeah, this is going to help us write a code. So here they have 2 pins at the output, that is trigger and the echo. Now in trigger, it is expecting that the pulse should be of 10 microseconds, and as soon as this pulse comes, internally it is going to transmit a sound burst, that is sonic burst, and the distance and the return sound is also captured by the sensor, and at the echo pin, at this pin, it is going to give us a pulse, and this pulse duration is deciding what distance we have from the sensor and the obstacle. And depending on the distance, the value of this pulse, the timing value of this pulse could be from 100 microseconds to 18 milliseconds. And if there is no obstacles, since the sensor range is 400 centimeters, there is no obstacle in between 400 centimeters, then the pulse width is going to be 36 milliseconds. So with this, we get to know whether the obstacle is present or not. And this timing diagram is going to help us write code. Now let's jump onto our Arduino sketch and let's write a code for this. So we are interested in using these 2 pins, echo and trigger. So trigger pin is going to be output for sure. Let's call this as trig pin. I'm going to use pin number 2 for my trigger, and similarly we'll use echo pin. Okay, echo pin, let's connect it to pin number 3. And in setup, we are interested in changing the direction of the pins. Okay, so as we have decided our pins to use, now let's configure them as input or output. So we have this function called pin mode, where I need to make this pin as output. And similarly, the echo pin is going to go input. Let's start with the serial port as well. Now let's start with the serial port as well. Let's make this as 9600 baud rate. delay microseconds. Microseconds here, let's give it a low pulse and then we'll make it high. Okay, then we'll make it high, and after 10 microseconds we are going to make it low. Okay, so we are going to make it low. Now with this, what has happened, that we have given a 10 microsecond pulse. Now we are interested in reading pulse. So before that, to read, we need to create a variable. Now duration, because this is the variable where we'll be holding the timing value, how much duration does it took to take that pulse. Duration and distance. Okay, duration and distance. So duration and distance, let's read our pulse. Pulse in echo pin. And what is the nature of our pulse? It is high. Yeah, so this is where it is going to, this function is going to give us the pulse duration in microseconds. Yeah, so let us understand what to do with the duration. Let's jump onto our datasheet again. So here I'm going to get this pulse, and how this pulse is going to represent my distance. So let's come here. We know speed of a sound. So if we multiply it with our duration, and if we multiply it with the sound, that is when we are going to get the distance of the sound wave. But since the sound wave is traveling in two directions, like right from the transmitter to the obstacle and from obstacle to the receiver, so if we divide it by 2, we will get the actual distance. So this is where the formula says that if we multiply it with the sound of the speed of the sound, and we multiply it with the duration and divide it by 2, we are going to get our distance in centimeters. Okay, so that's what we are now going to do. That let's copy this out. Yeah, so we are interested in doing this, and this is going to be constant. Duration, this is going to be our distance, and let's print this out, right? And let's give it a delay of 100 milliseconds, and after every 100 milliseconds it is going to transmit as the distance. Okay, so we are good to go. That we have given a pulse on the trigger pin, we are expecting a pulse on this echo pin, and we are going to get the duration. Duration multiplies with the sound speed, and we are going to divide it by 2, since our pulse is going to transmit in two directions, and we only want our distance in one direction, so that divided by 2. And then let's print this out on the terminal window. Now let's connect our Arduino board and port this code onto our board and connect our ultrasonic sensor, and let's measure on the hardware. So here I have this ultrasonic sensor connected. These are the pins, right? VCC, ground, trigger, and echo. So I've connected a separate wire to it, and now I'm going to connect it to our board, right? So let's connect first VCC and ground. Yeah, so we have connected our sensor, and let's now try programming it. Yeah, so this is how we have connected our sensor. Ground is connected to ground, VCC is connected to VCC. This yellow pin is our trigger, and green is the echo. So this is how we have connected our sensor to our Arduino, and we are going to program it now. Yeah, so it has done the uploading part. Now we should be expecting distance over our serial port. Let's check that. Tools, serial monitor. Yeah, so we have something on here, but we don't see any distance. Let's check with our pin connections, wiring. Perfect. So it has done uploading. Now let's check this on the serial port. So here we have serial monitor. Yeah, this shows me some distance, and I'm good to go. Let's put our hand in between on the sensor. Yeah, so this is how it is giving me the distance values. Yeah, the scale starts from here. Now it is, I'm at 4 centimeters. I'm at 4 centimeters, and it is quite accurate. If you are interested in using ultrasonic sensor, code link is in the description box below. And if you are interested in understanding servo motor, here is the link for you. And if you want to understand the application of servo motor and ultrasonic sensor, so here is the link for application of radar. And here in this application, I've used ultrasonic sensor, servo motor, and Python code to represent my radar. So it's quite an interesting application. Go check that out. If you have liked this video, give it a thumbs up and subscribe to my channel and press that bell icon so that you get notified whenever I upload new videos. That's it for now. See you in the next video. Bye bye.